Welcome to Masterminds in Maintenance, a podcast for those with new ideas in maintenance. I'm your host. I'm Ryan. I'm the CEO and founder of Upkeep. Each week, I'll be meeting with a guest who's had an idea for how to shake things up in the maintenance and reliability industry. Sometimes the idea failed, sometimes it made their business more successful, and other times their idea revolutionized an entire industry. Today, I'm super excited. We've got Howard Penrose here on the show with us. You've got over 30 years of experience in predictive maintenance, maintenance testing, and you're also the president of MotorDoc LLC. From my understanding, you've also got a PhD, so you've got quite the breadth of experience working in this industry. You know, I know that you own the company MotorDoc. It's a veteran-owned small business that provides industrial and commercial consulting, training, technology for electrical and mechanical systems and reliability. You know, I also know that you're on the chair for the SMRP for the years of 2017 to 2018. Howard, huge welcome to you here on the show. I'm super excited to be chatting with you.
Oh, thank you very much, and I'm very glad to be here.
Well, great. I'm super excited. You know, I know quite a bit about your background. I've been following you and your journey for quite some time now, but I know that all of our listeners may not have that experience. Maybe you could start us off a little bit with your background and how you got started in this industry and field.
I actually got into this industry deliberately. And it started in high school, and when I became part of the Vocational Industrial Clubs of America and got involved in lubrication technology as a chemical technician at the oil labs at Amoco Labs in Naperville. I then joined the Navy, and my worst subject in school, in A school, was electric motors. So I don't like failing. So I, of course, made that my best subject. Something I became known for, especially when I went to the Navy. And within the first year, started running the motor repair shop, taking care of up to, I think it was 38 ships in our battle group. And I became a motor repair journeyman, the youngest in the Navy, by the time I was 20. In that, I learned balancing, vibration, mechanical systems, pumps, fans, field balancing, and a number of other technologies well before they were really popular. I was approached by the University of Illinois to come in and do some industrial engineering courses, and also as an adjunct professor, but also to be the senior research engineer for the Energy Resources Center. I finally took the leap and got back into consulting on my own. In parallel with that, I'd been involved with IEEE on a variety of standards groups since 1994. So I had been in touch or talked to or worked with the top insulation and machine design folks in the world.
Yeah, you've had some pretty big accomplishments in this space, in this field. And, you know, I know particularly that you've been focusing a lot of your more recent time and experience on current electrical signature analysis. You know, maybe for the layman, could you walk us through a standard current signature analysis and what that looks like?
I actually started likening it to if you're a vibration analyst, you take a look at the signature, stand on your head and cross your eyes, and you're looking at the same thing you do in vibration. It's an amplitude modulated signal. So what you end up doing is you go in and you collect. If you are using, I have my specific equipment that I like to use, but if you're using a vibration data collector, because all of the filters, the FFT systems and everything are identical. So you go in and you are close to identical. You go in, you collect the data in current. I think CSI used to have a data collector that could do that. And then you analyze the data, except because the carrier frequency is the line frequency, you have peak pairs instead of individual peaks. And what's phenomenal about that is if I'm a vibration analyst and I go in and I have a bearing issue and I know what my multipliers are from a bearing database, so I'll pull up and say, okay, outer race is 2 point something times per RPM or per hertz. I can take that and apply it with an electrical signature analysis and do the exact same thing. Mm-hmm. This times speed is this. That's it.
So when do you use a current signature analysis versus a vibration analysis?
I will let you in on a little secret. For a long time, the industry, the discussion within the industry is whatever we do, don't say we can detect mechanical issues. Well, why not? Well, because we might get the vibration guys angry. Well, who cares? I'm a vibration guy. I'm not angry because I can go with an electrical signature analysis. And here's what I do. So I generally use it. That's my system analysis. Because I'm using the magnetic field between the rotor and the stator of a motor or generator of any type and any size, I can see everything going on downstream in current all the way to the pump and some of the valves and whatever else in that system. I can see the power quality going upstream as far as sometimes even past the transformer, but it'll come to a wall if I'm doing most VFDs. I can test upstream. I can see what the condition of the controls are and everything else by using the motor itself as a transducer. Vibration in the wind industry is determined to be about 56% accurate. The electrical signature right now has been determined to be greater than 90%.
Wow.
Now, what is the primary difference and why is that? Electrical signature is a system analysis. There's things we will detect much later than vibration or ultrasound and other things, but we will see them. Mm-hmm. And there's things we'll see that they will never see, but we're going to see it all at once. So I take one set of data. So in the with most wind turbines, I'll walk into the base of the tower, take a 1 minute set of data from the base, not have to climb. And I will have more data than at any load. Yeah. It's not load dependent than what they get with setting the vibration data stuff up tower. That usually takes about a day a tower to run their analysis.
Yeah, and I can imagine a big benefit to that too is the accessibility of being able to run these electrical current analyses versus having to do a longer term vibration analysis.
Yep.
Vibration, ultrasound, thermal. I'm curious from your perspective, why did you choose to focus your most recent career on electrical current analysis?
Because very few people were doing it.
Yeah.
The reason I got into electric machines is because I got out and I looked around. I wanted information that wasn't there because everybody was retiring or nearing retirement or died. There was very few people getting involved. I mean, how many engineers do you know that design motors on paper still? That's gone. They rely solely on software. So as things went on, I was looking at all the different technologies. I felt there was something missing, and then I ran into electrical signature analysis, and I saw its possibilities, and I saw that really it hadn't advanced.
Yeah, you chose this career path because no one else was doing it, and you said, "Hey, I have the skills. I have the ability to go out and learn. I want to push this industry forward." That's amazing. It's the beginning of this new decade. We're January of 2020 now. Where do you see the future in the next decade of electrical current analysis technology going towards? What are you excited by?
I'm excited because it's finally being accepted. So I'm watching different industries picking up on it very quickly. Some of whom are trying to figure out, quote unquote, how I've done things, like how I do a wind turbine. That's proprietary, but I'll teach people how to do everything else. I'm seeing more people when I go to the Vibration Institute and the Mobius Institute and other places where I'm talking about the technology. The crowd, which used to be, 8 to 12, is now a packed room. It's evolving. I see it as being built into controls and related technology in the next decade.
What do you think are some of the biggest challenges for electrical current analysis technology to be in the future?
So everybody tells me cost, and I kind of laugh at them because if you're thinking in terms of cost, you got a small mind. I always say that, and if you're a salesman trying to sell based on cost, you shouldn't be in the business. Electricity is scary. So how do you collect data for electrical signature analysis? Well, if you got a data collector like I do, you're usually opening a panel.
Yeah.
So you've got all the arc flash stuff that goes with that, or you go in through for medium and high voltage stuff, and now you have to wear arc flash stuff and go straight to the 120 volt CTs and PTs. So for medium and high voltage, you're never really exposed. I think the primary thing has just been electricity is mysterious.
People just don't know enough about what's dangerous, what's not. And I think there is a very valid point to say that there are parts of electricity that are very dangerous and very scary.
Oh, yes. I've seen my share.
Yeah. But I think what I'm hearing from you is it's more about understanding, learning, educating the entire industry on like what is scary, what is not scary, what is okay to do, and where you can drive the most benefit and value using and analyzing electricity. What's one thing you wish people knew more about maintenance and reliability, and maybe more specifically, electrical current analysis technology?
From the analysis, well, I've actually got two responses to you. From the maintenance reliability industry, stop being hung up on your bosses knowing what you do. Everybody's so focused on the C-suite these days. You know, I'm sure you've seen some of my writings along this line. I'm going to be getting a little heavier into it. When you start relating reliability and maintenance to safety, to reduced waste stream, to reduce cost per unit of production, to you know, reduced energy costs, things like that, and stop with the you know, simple payback is, I always thought was hilarious. But the other one, cost avoidance, I have yet to pull up a P&L sheet and see cost avoidance on any column. You know what I mean? So we've done, I keep seeing it, and I've watched it for decades, and I always try to get the message out, stop. The minute you start tying the technology, the methodology to something that's measurable, you're going to get attention. They will mention it a little bit more. Mm-hmm. It's nice, but the biggest thing there is communication still. From the technology standpoint, a lot of people need to start looking beyond. They got to get out of their safe zone. Everybody likes safe zones. You know, they have to start learning that there are other technologies that can do the things that they're used to doing with another technology, and that the technologies actually work together. Learn your technologies, understand what they do. I mean, who's doing a great job of that right now? Look at UE. I mean, they went from, okay, you know, we're ultrasound and we detect air leaks, to, oh, we can do bearings. And by the way, we can accurately detect stuff. Now they're rivaling vibration.
Yeah.
So because they're learning more about what their technology can do.
Well, Howard, this has been a pleasure. This has been quite the wealth of knowledge. You know, just to wrap things up, you know, what are all the different ways that our listeners can continue following you on your journey and learn from you? Where can they go to connect with you?
LinkedIn under MotorDoc, and or my name, Howard Penrose. My website, motordoc.com, MOTORDOC, not dot, but doc.com, which links to a lot of different things, lots of free papers and everything else. And then Facebook, if you want to see a lot of heavy weights being moved.
I've seen some of those. They look great. Thanks so much, Howard. I really appreciate it. Thanks for joining us on today's Masterminds in Maintenance. Again, my name is Ryan Chan. I'm the CEO and founder here at Upkeep. You can also connect with me. I'm pretty active on LinkedIn, or you can reach me directly at ryan@onupkeep.com. Until next time, thanks so much, Howard.
Thank you.